Welcome back to Auto News Talk. I am so glad you're here because today we are heading straight into, I think, the eye of the storm.
It really does feel that way, doesn't it?
Yeah. For the last few years, everyone talked about the EV transition like it was, a simple swap.
Right. Take out the engine, drop in a battery, call it a day.
Exactly. But what we're seeing right now, based on these reports, is something totally different. The industry is trying to solve this impossible math equation.
hmm
How do you slash the cost of an EV to that magic $30,000 number without going bankrupt?
It really is the billion-dollar question. And the answer isn't just cheaper batteries.
Okay.
Not anymore. To hit that price point, automakers are having to rewrite the absolute fundamentals of how cars are built.
And how they're valued and even how they're sold.
It's a fundamental shift in the actual hardware of the industry.
It feels like a high-stakes poker game.
For sure.
On one hand, you've got manufacturers betting on these secret Skunkworks teams and just radical engineering.
Trying to save the bottom line.
And on the other, you have the dangerous physical realities of what happens when that new manufacturing tech goes wrong.
And we're going to see a perfect example of that.
It's a journey, right? From the design lab to the factory floor.
You're finally to the used car lot. And yeah, the terrain is shifting under our feet in all three places.
So let's unpack this. The biggest headline, the holy grail right now, is that $30,000 EV.
Everyone wants it.
Consumers, regulators, shareholders. But building it profitably, that's been the impossible hurdle.
Until now, maybe. It seems Ford is hitting the reset button to try and solve it.
And reset is the right word because the current lineup, like the F-150 Lightning,
Yeah.
great truck.
Great truck, but it's essentially a gas car frame, just stuffed with batteries.
It works, but it's heavy, inefficient, expensive to build.
Exactly. They realized they couldn't just keep adapting old designs, so they're rolling out something called the Universal Electric Vehicle Platform, UEV.
UEV. Okay, sounds very
Wow.
encompassing. But it's not just a buzzword, is it? This is a whole new architecture.
Completely new. And the goal is incredibly specific. A $30,000 small electric pickup launching around 2027.
Okay, but how are they getting there? Because that's the fascinating part.
Well, they realized the standard corporate process would kill the project, so they spun up a Skunkworks team.
I love that term, Skunkworks. It sounds like they're building a spy plane, not a pickup truck.
In a way, they kind of are. The team was small, isolated, and led by Alan Clark, who's an ex-Tesla engineer.
That makes sense.
And they operated with this totally different culture. They used an internal bounty system.
A bounty system, what does that mean?
It's basically, they were hunting for efficiency. If an engineer could find a way to cut weight or reduce drag, there was a reward.
So it turned engineering into a hunt.
Exactly. And that hunt led them to some really specific technical changes that are, frankly, game changers.
Okay, lay it on me. I saw the report mentions a move to a 48-volt low-voltage architecture. Now, why is that a big deal?
It's huge. It's basic physics. Most cars today run on a 12-volt system for their lights, wipers, windows, all that.
Right, yeah.
But think of electricity like water in a pipe. At low voltage, low pressure, you need a really wide pipe, so thick copper wire, to move enough power.
So by jumping to 48 volts, you're increasing the pressure.
You've got it, which means you can use a smaller pipe,
A thinner wire.
much thinner, lighter wiring.
Okay.
And when you do that across a whole truck, the savings are massive. The report says that in this new truck, the wiring harness is over 4,000 feet shorter.
Wait, what?
4,000 feet shorter and 22 pounds lighter than the one in the Mustang Mach-E.
4,000 feet. That's almost a mile of wire just gone.
Gone. And 22 pounds might not sound like much on a 2-ton truck, but in the EV world, mass is the enemy of range. It all spirals.
A virtuous cycle.
You save weight on wire, you need a little less battery. You need less battery, the truck gets lighter again. Plus, copper is expensive, so you're saving weight and money.
Which brings us to the battery. They're using LFP cells, lithium iron phosphate. We're hearing that acronym a lot.
It's the key to that $30,000 price tag. LFP is about 20 to 30% cheaper than the usual nickel-based batteries.
Okay, so they're cheaper. What's the catch?
There's always a catch. They're less energy dense, so they're heavier for the same amount of power.
Okay, wait. If the battery's heavier and holds less juice for its size, how are they hitting any kind of range target?
Aerodynamics. Extreme, obsessive aerodynamics. The source notes this pickup will have 15% less drag than any pickup currently on sale.
I read one detail that blew my mind. They combined the mirror motors into a single unit.
Right. Usually you have 2 motors per mirror, up, down, left, right, and they engineered it to work with one just to make the mirror housing a little bit smaller.
And how much range did that save?
An estimated 1.5 miles.
1.5 miles. From a mirror motor? That's obsessive.
It is, but that's the bounty system. When you use a cheaper, heavier battery, you have to squeeze every single mile out of the air. It shows the difference between adapting a car and building one from scratch.
Okay, so we've got the design. Thinner wires, cheaper batteries, obsessive Aero. But building it at scale, that's a whole other problem.
That's the crucial transition. To make them cheap, you have to make them differently. You can't just weld hundreds of little stamped pieces together anymore.
Too slow, too expensive.
Right. So Ford is betting big on gigacasting, or as they call it, unicastings.
This is the Tesla technique, right? Casting one giant piece of aluminum instead of welding.
Exactly. The report says the new pickup will have 2 massive castings, one for the front, one for the rear. Those 2 pieces replace what would have been 146 separate components in a gas truck like the Maverick.
146 parts, down to 2. I mean, for speed, that's incredible. The source said they're targeting 15% faster assembly.
It's a manufacturing dream. But, and we have to connect the dots here, it introduces a massive new risk.
A massive risk. How so?
When you rely on a single casting, the quality has to be perfect. If you mess up a weld, you fix the weld. If you mess up the entire front end of the car in one go,
You have a very expensive piece of scrap.
or worse, the defect isn't caught and it ends up on the road.
And that leads us to a pretty sobering reality check. While Ford is planning this, we have a report from Auto News Talk about Hyundai that shows exactly what happens when casting goes wrong.
This is a really important counterpoint. We're looking at a recall for over 4,500 Hyundai Konas.
Okay.
Now, to be clear, these are the gasoline models, not EVs.
Mm-hmm.
But the problem is a manufacturing defect in a cast part. The front steering knuckle.
The steering knuckle. Remind us what that part does.
It's critical. It's the pivot point. It connects your wheel to your suspension and your steering. It takes all the abuse from the road.
And the report says these were incorrectly cast. What does that mean?
It means they have defects. Most likely porosity, voids inside the metal.
Porosity, so like air bubbles?
Exactly. Tiny pockets of air trapped inside the molten aluminum as it cooled. You can't see them, but they weaken the whole structure.
And the consequence?
Fracture. Under high loads, hitting a pothole, braking hard, the knuckle can just snap.
And if that happens?
You lose steering control. Immediately.
That is terrifying. You hit a pothole and your wheel just does its own thing.
It is. And while this is a Hyundai issue on a gas car, it's a huge warning for the whole industry. If you're betting the farm on massive castings to hit $30,000, your process have to be flawless.
It's a high wire axe. Efficiency on one side, physics on the other.
And that physical reality is what makes this whole race so dangerous. Everyone's cutting parts, cutting wires, but quality control becomes the firewall between profit and disaster.
Okay, so we've talked about how they're building them and the risks, but I want to pivot to what happens once these cars are on the road, because there's a huge disconnect in how we value EVs.
This is one of the biggest shifts for consumers. For 100 years, the odometer was the Bible, right? High miles, bad car.
Yeah.
Low miles, good car.
Of course. I see 90,000 miles on a used car. I assume it's tired. Nearly dead.
And for EVs, that instinct is just wrong. Auto News Talk share data from the Generational Battery Index, and it completely busts this myth.
Oh, so?
They found that mileage is an unreliable predictor of battery health.
Unreliable? I mean, the whole used car market is built on mileage bracket.
But the data is clear. They looked at vehicles across 36 manufacturers. Average battery state of health, or SOH, was over 95%. But here's the kicker.
Go on.
A 3-year-old fleet EV with 90,000 miles might have a better battery than a 6-year-old car with only 30,000 miles.
Wait, unpack that for me. How can the car with 3 times the mileage have a better battery? That goes against everything.
Because batteries age differently than engines. An engine wears down with friction. A battery degrades with chemistry. It cares about charging habits, heat, and what's called calendar age.
Calendar age.
Just existing. A battery degrades over time even if you don't use it. But what's worse is sitting at 100% charge in a hot environment.
So that low-mileage car, the garage queen.
Exactly. Maybe it sat plugged in at 100% all summer in a hot garage. That's cooking the battery chemistry.
Meanwhile, the fleet car with 90,000 miles
Is driving constantly. It's cycling. It's probably being managed by software to optimize charging. It's getting airflow. So even with all those miles, The chemistry might be fresher.
This changes everything for the used market, doesn't it? The bank is looking at the miles for the loan value. I'm looking at the
And
miles.
that's the problem. We're using combustion logic for tech hardware. Lenders, dealers. They need to stop looking at the odometer and start demanding verified battery diagnostics, a state of health report.
It's almost like buying a used smartphone. You don't ask how many emails it sent. You check the battery health percentage in the settings.
That's the perfect analogy.
Yeah.
And until the market catches up, there are going to be good cars undervalued because of high miles and bad cars overvalued because of low miles.
So if I'm hearing you right, the odometer is basically lying to us.
In the EV world, yeah. It's a metric that measures distance, not condition.
Okay, so let's zoom out. We've got Ford reinventing the assembly line. We've got Hyundai showing us the perils of casting. We've got the used market realizing the odometer is obsolete. It just feels like chaos.
It is chaos. It's a transition period.
But, and here's where it gets really interesting, despite all this chaos, the business of selling cars remains incredibly lucrative.
It is surprisingly resilient. You'd think with all this uncertainty, the traditional dealership would be in trouble.
Right. People have been predicting the death of the dealership for years.
But we have a report about Keeler Motor Car Company and Open Road Capital that suggests otherwise. They just made huge acquisitions in the Northeast.
What'd they buy?
Lexus, Toyota, and Audi dealerships in Westport, Connecticut, and Hawthorne, New York.
I know those areas. That's the Gold Coast. That's not cheap real estate.
Not at all. These are incredibly high-income areas. And according to the source, dealership valuations are near all-time highs. Investment groups are paying top dollar.
Even with the shift to EVs.
Especially for high-margin brands like Lexus and Toyota. The source says the appetite for luxury franchises is voracious.
So it's this fascinating contrast. You have Ford counting pennies, cutting miles of wire to save money.
And on the other hand, you have investment groups dropping millions just to buy the right to sell the cars.
Why? What do they know?
It shows that the retail side, the handshake, the service bay, is still where the steady money is. Even as the hardware changes, the software of the business, the human transaction, remains.
That's a great point. If cars are getting more complex, you need a guide.
You need someone to explain the state of health report to you. You need a certified center to check that steering knuckle. The dealer becomes the guide through all this confusion.
Okay, let's try to synthesize all of this. We've covered a lot of ground. Ford's, Skunkworks, Hyundai's casting headaches, the battery index, the dealers. What's the thread here?
I think the central thing is radical efficiency meets reality. You have Ford pushing for radical efficiency, the 48-volt system, the unicastings, just to survive.
But then you have the manufacturing reality check.
Right. The Hyundai recall is the anchor to reality. It reminds us, you can't innovate physics away. If you cast metal, it can crack. Quality control becomes the most important tech in the factory.
And then there's that valuation gap. We're building these futuristic machines, but judging them by 1990s standards.
That's what the generational battery index proves. The market is lagging behind the tech. We're pricing cars on miles when we should be pricing them on chemistry.
It's a messy transition period.
They're always messy. But that's where the opportunity is. If you're a buyer who knows mileage doesn't matter as much, you can find a bargain. Knowledge is leverage.
So what does this all mean for our listener, the person maybe thinking about their next car?
It means the sticker price and the resale value are both being rewritten. If you're looking at a new EV, realize the cost cutting is changing the fundamental architecture of the car. It's leaner, but it's newer tech.
And if you're looking at used,
Ignore the odometer. I mean, don't ignore it completely, but don't let it rule your decision. You have to ask for the battery state of health. That number tells you the real story.
that's the takeaway of the day. The odometer is lying to you.
In the EV world, yeah, pretty much.
I love that. Listen, this has been another incredible session here on Auto News Talk. It's wild that a steering knuckle in a Kona and a wire harness in a Ford are telling the same story.
It's all connected. Manufacturing, design, valuation. You can't pull one thread without moving the whole web.
Before we go, I want to leave you with a thought. We talked about the $30,000 EV being the goal, but is it actually a car in the traditional sense, or is it really a test? A test of whether we can strip manufacturing down to the bone without breaking it?
That is the question. And we'll probably find the answer in the service bays a few years from now.
Something to think about. Thanks for listening to Auto News Talk. Keep an eye on those state of health reports, and we'll catch you on the next deep dive.